Hello guys. Alright, so in this video we're going to create a simple scene, set up a few game objects, or honestly we'll probably just set up one or two game objects, have some scripts and behaviors attached to them, and I will also show you guys how to create prefabs. So like I talked about in the last video, in the last video I showed you guys how to start a new project, or what is the best way to start a new project. So now I have this branch called demo project, and yeah, we're going to start from scratch and create a game. So right now the demo project does not have anything other than the engine file, so the only folder is the engine folder. I'll quickly give it a run. Yeah, so nothing happens, blank screen, just like the default game in the master branch was like. So we'll start off by creating a folder for our project. So I'll say add new filter, give it the same name as in the project, so I'll call it demo project. Oh no, that's not what I wanted. Okay, demo project, there you go. And that's what I called it, right? Yeah, demo project. Okay. So to create a game, the class that runs your game is going to be of type game. So we're going to create a new class, call it demo project game, and it will be of type game. So like that, so it inherits from game. Now the two functions that you want to override are going to be, if I look into my game, or in my main.cpp, so you can see we call game awake, then we initialize, and then we call setup, and then we call update. So that's the order in which things happen. So awake is something you want, anything that you want to set up before your game starts. That's where you do it. So init is what initializes your renderer. It initializes your window, the game window. So anything you want to do before any of that happens, you will use the awake function to do those things. And once the window is initialized, you will use the setup function to spawn your game objects, set up your scene, so on and so forth. So that's the idea here. So let's go into our game. I'll put those in the right folder. So the two functions that we need to override are void awake and void setup. Now in the past we had spawned all our objects directly in the game. Actually, first before I continue, let me just quickly add those functions in the CPP file. So they're going to be, oh no, come on, there we go. So awake and setup. Okay, so in the past we were setting up all our game objects in the setup function. We will do something similar, however now we have the concept of scenes. So scenes are basically going to be separated by a loading screen. Right now there is no loading screen, eventually there will be, but we can already start separating our game into different scenes. So for example, your game could have the title screen, which will have some options, and then once you hit new game or continue, it'll go into your game screen, which will be a separate scene. Then you can have multiple levels within your game, which will each be their own scene, and finally you might have end game scene, end game credits or something like that. So they will all be broken up into separate scenes, and we will now spawn our game objects, do all that stuff in the scene. So let's go ahead and create a scene. So we'll create a new class, let's just call it scene1 for now, and it will inherit from scene. So there we go. It's of type scene. So scene is very similar if you go into the class. By the way, F12 is a shortcut to quickly navigate to a definition of a class, a function, whatever you have. So scene, the main function we are concerned with is the setup function. Just like the game, the scene has it set up, which is where we will now be spawning our game objects. So void setup and scene dot setup. Return type is void. So there we go. So this is where we would spawn our game object. So how do we do that? So we'll say game object. So let's just create the player game object. So we'll say game object player. Now the function I want you guys to use for creating new game objects is going to be the instantiate function. In the past we had used the create game object function, and I think there was something else at one point, but from now on, anytime you want to spawn a new game object, you use the instantiate function to do that. So we'll say instantiate, give it a name, we'll call this up, we'll give the name as same as the object player, and give it a default position. So I want to spawn it at the center of the screen, so I'll say camera. So camera is something that needs to be included so that I can use its properties. So I'll include camera, and then I want to spawn it at camera dot width by 2 comma camera height by 2. So there we go. That's our player game object. And now, like I had explained in the past, it's a good idea to generally keep your art separate from your main game object. That's just because it's nice to have your parent game object have default orientation scaled to 1:1 and all that stuff. So whenever you're doing math with them in the future from your scripts, you're guaranteed that your parents will have the default values for transform properties. Also, it's good when you want to run animations and things like that, you have all that running on a separate object. So we'll create another object called player graphic, which is where we'll put our sprite renderer. So the code will be very similar. We'll spawn it there. Now I'll call it player graphic. However, now I will spawn it at 0, 0. Why? Well, you'll see in a bit. And then to connect them, I will say player graphic dot transform dot, oh, I need to include transform dot, I think I need to include game object as well. Okay, so now there we go. Transform dot set parent. So this is what I want to do. Set parent. What does set parent do? Now set parent will, to parent this player graphic object to whatever I set the parent to. In this case, that would be the player. So I want to do that. Now this will work. Actually, I'll first show you guys how this will work. Oh, by the way, what we're parenting is not the player game object, it's the transform. So the parent-child relationship happens on the transform level. So just keep that in mind. Oh, my mic was turned off, so I'm not really sure. Let me just quickly make sure it was recording till now. Where is it? Hello guys. All right, so in this video, hello guys. All right, I'm not really sure. That probably looks weird, seeing the video recording, but at least you should be able to hear me now. I think it was running till to a good point. I don't know when it turned off, but all I have done is created the scene. I have added the scene. I have added reference to the scene. Or rather, I'm setting my current scene to scene 1 in my game, and the last thing I have to do is set my game to the demo project game, so that's what I run. So I will say demo. So we can actually get rid of this. It doesn't matter because, you know, it'll only be included once anyways, but since demo project game will have the game class as the game class header and it's include, so we're good. So that's it. Let's just run it, see what happens. Oh, there's an error. What is the error? Unresolved external. Why is that? So we have white setup. Huh? What is the problem? Why is... it's right. This is scene1.setup because scene.setup is something else altogether. There we go. Okay, so that should be good. There we go. So that's what we have. So we have the player here at the center, and the graphics, remember, why has it spawned at 0, 0? Because, well, that's exactly what we set it to. If we look at our scene.cpp, our player graphic, it's spawning at 0, 0. Now, why did it do it like that? Now, of course, I could also pass in camera width by 2 and camera height by 2, and that'll set the position. Or what I can do is use set parent relative. What does that do? That does set the transform parent to whatever object you're setting it to. So that part is the same. However, while setting the parent, it reads the value of position and also angle as relative to the parent. So now set parent relative is going to say, oh, it's going to be 0, 0, not with respect to the world, but with respect to the player. So I'll save that and run that. There we go. So now it's at the center of the center of the screen. So that's cool. The next thing is, yeah, this is too big. I probably want my player to be smaller than the size that's the default size right now. So let's say I want the player to be 1/10 of what he is. So I can do this in many ways. So the easiest would be to say player graphic transform set relative scale to vector 2, or you know what, we'll set absolute scale. So set absolute scale to vector 2, vector 2 0.1 0.1. So 1/10 of the size. So let's see. There we go. That's better. That's about the size I want it to be. So what is set absolute scale? It sets the scale with respect to the world. You have something similar called set relative scale, which will scale it relative to the parent. In this case, it doesn't matter because the parent scale is 1, 1, the default scale. So whether you set it relative to the world or the parent, it'll be the same thing. So that's it. We have spawned a object in the scene, and we have loaded that scene in the game. What is the next thing we want to do? So I want to add controls to this object that I've spawned. It's my player. I want to be able to move it around with, say, WASD. So for that, whenever you want to attach properties, a custom behavior to any game object, you will create a script inheriting from behavior. So I will create a script called player controls, and I will inherit from behavior. And okay. So what is this player controls going to do? It's going to move the player when I press WASD. So I will need some parameter speed to control how fast I move when I press those keys. So I'll set public float speed, and all my code will happen in the update function. Every frame, I'm going to check for these inputs, see if I press any of these keys, and then move the player according to that. So void player controls set, oh, not setup, update. All right. Yeah. Okay. So player controls update. What do I want to do here? So I want to check for the two keys, or the four keys, W, A, and D. So I'll include the input header so that I can use the input functions. And let me create a vector 2 called direction, so that I can combine the inputs and the X and Y axis and get a combined vector. So I'll say direction.x. So what determines my X direction? That'll be whether I'm pressing the A or the D key. D will move me to the right, A will move me to the left. So I'll say input get key. So there's get key down, and get key up. So get key down is just the frame in which you start pressing the key. Key up is when you let go of the key, and get key is all the frames in between. So this is a hold function. I want to hold D and move to the right. So I'll say input.getKey, SDLTD. Then the value is 1, or if it is A, then the value is, oh, missing an I here. If the value is A, then it's -1. Otherwise, it's 0. So that's my X direction. So that, by the way, it's a ternary operator. It's not something I use all the time, but sometimes when you have a very simple case break or an if-else statement, you might be able to just write it like this, make it really short. So that's it. This is saying if the input is 1. So the question mark is is the value, it's a Boolean expression. So if that Boolean is true, if this Boolean is true, then this is the value. If it is false, then this is the value, which itself is a ternary operator, which is saying within that, if this is true, then the value is -1. And finally, so basically D maps to 1, A maps to -1, and the default value is 0. We'll do something very similar for the Y direction, except you have to remember in STL, or the way our world is set up for the game engine, our Y-axis is pointing downward. So S is the positive Y-axis, and W is the negative Y-axis. So that gives me the direction vector, that the direction the combined effect of both the inputs. Now, since this is a direction vector, I just want to get the angle from this, not the magnitude, so I will normalize it. Normalizing makes it a vector of length 1, and then finally, once I have it normalized, I will say, move me in that direction by that amount. So for that, I have the transform, so I obviously need to change properties of the transform. So I'll also need to include game object and include transform. All right, there we go. So now we can say game object transform dot set. Now there are a lot of functions on the transform to set position, rotation, orientation, and that sort of stuff. So for position, there is set absolute position, set relative position. Absolute position is with respect to the world, relative position with respect to the parent. But then there is also absolute position delta and relative position delta. That means if you know exactly where your object is going to be, then just use absolute position or relative position. But if you're moving the object by a certain amount, so this input check or the direction that I've got, I want to move the character. Sorry. Yeah, so we want to move the player in that direction no matter where they are. So in this case, I will use set absolute position delta, and that delta is going to be in the direction multiplied by speed multiplied by time dot delta time. Now I need to include time as well. Why time dot delta time? That's the time passing between two frames. So that's what I want to multiply it by to get a smooth movement. So I'll include time so that I can use time functions. Delta time, time dot delta time. And there we go. So that's it. That will, we get the keys, get the direction, move our character, multiplied with speed in that direction. Let me put those in the project folder. And now we'll go to our scene and attach this to our player. So we'll have to include this script, the header for the script, and then I can attach that to my, so what do I attach it to? I should probably attach it to the player. I don't just want to move the graphic, I want to move the entire player object. So I'll say player dot add component new player controls. So now player controls should be added to the player game object. They'll be called on update. Every frame it'll check for inputs and move the character. There we go. I'm pressing WSD and I'm moving my character. Now that's really slow, so I should probably increase the speed. How do I do that? One way of doing it would be this. You can say player get component player controls dot, we know we have the speed variable on it, and so let's say the speed to 500. It was 100, we'll say it. Now so what does this get component do? So get component is a what do you call it? A template function. So you can pass in a type and it will give you a component, it will give you the first component of that type. So you can pass in any type that you want and it'll go through the list of components on the player, see the first instance of a component of that type, grab it and give you back its reference. If it doesn't find anything of that type, it'll give you null. In this case, we obviously know we have just added the player control, so we know this exists. And you're grabbing it and you're setting this value of speed to 500. So now, yeah, that's a lot better. That feels a lot more responsive. So that's it. That's it. In this case, this is a little redundant. I know I'm creating an object and then going through a list and trying to find that object, even though in this case there is only one object in the list, so it's not bad at all. However, a better way of doing this would be creating the player controls as an object. So I'll call it control. And then setting the value of speed on that object to 500, and then add that object to the player. And then that way, I'm not searching through the list of components on the player. I'm creating that as an object, setting that on the player. That's it. So yeah, we got movement on our player. Now the problem is our player is not facing the direction in which it's moving, so that's not what we want. I want to calculate from the direction vector that we have, which we already have over here. Using the direction vector, I want to calculate the angle which I should be facing. So how do you get angle? So let's say float angle equals a tan 2. So yeah, a tan 2 is a good function to get the angle. It gives you a unique angle given the value of y and x. So I'll give direction.y and direction.x, and that'll give me the angle that this direction vector is making with the x-axis, because the way SGL is set up, the way our engine is set up, all the angles are calculated from the x-axis. So that's the angle, and then all I want to do, just like we set the position using set absolute position delta, we have a similar function on transform called set absolute angle. So yeah, in this case, we're not trying to set the absolute angle delta. The direction gives me the exact angle I want to be at. So I will set absolute angle to whatever angle we calculated. But remember, that's in radians. We have to convert it to degrees. So that divided by pi. Right? So that'll convert because our transform uses angles in degrees, just so because it's easier to read. So we need to convert that radians to degrees. And now our object, I don't need to do anything else because that script is already attached. Well, our object is rotating in the direction. What's happening right now? So what is this? This is, I'm not pressing any keys. So direction should be 0 in this case. So x is 0, y is 0. So direction itself is 0. And this is our, now what will the angle be? So we're doing a tan 2 direction y direction x. That'll give us an angle of 0. So this is the 0 angle. Now 0 angle from definition means the x-axis, because we are measuring angles from the x-axis. So the 0 angle is in the direction of the x-axis. So the default direction of an object is facing the x-axis. Obviously that is not the case here. Well, that's because the way our image is. If I go to assets, so our tank is facing upwards, not to the right, the default position for our engine. And this is probably going to be the case with a lot of images that you have. So what do we do? And this is why we have the parent-child relationship, because now all I have to do is rotate the child by 90 and I'm good. I don't care. I don't want to give an offset to the player game object, just the graphic game object, and then that way now the default orientation of the child is 90, and now when I'm moving, the parent is moving, that rotates the child, and life is good. Now there is another problem rather. So we fix the problem with angles. Now the problem is every time I let go of the key, no matter which direction I'm facing, I face back to the right. Why is that happening? It should be very obvious from the code. Well, the code is saying if I'm not this, the player controls. So player controls, we're saying, you know, set the X and Y values to whatever, depending on the keys you're pressing. But the default value is 0. So the moment I let go of the keys, the direction X and direction Y become 0. So all of this is 0, angle is 0, and we're saying set absolute angle to 0, which is the right side, the x-axis. So that's what is happening. What we want to do is, if we let go of the keys, how do you know we have let go of the keys? Well, if I have let go of the keys, that means the direction vector is a 0 vector. Now 0 floating point error, it might never be actually equal to 0. So what you instead want to do is check against a really small number and say if direction.length is greater than that, that means I'm pressing some buttons. Only then set the angle. So if I let go, if the direction becomes 0, I'm not going to set the angle. That means it will be at whatever angle it was at when I let go of the key. That was a mouthful. But yeah, so now no matter which direction I'm facing, I let go, it stays in that direction. So that's a much better player control. There we go. So that's cool. So yeah, we have a player moving in our scene. Well, what do we want to do next? Yeah, so let's add some enemies to the scene. So we have the player, we want some enemies. How do we add enemies? Now, unlike the player, we just spawn the player in the scene, in scene setup. Enemies are probably going to be, first of all, there'll be more than one of them. And then we might want to, spawn enemies at runtime if your game is wave-based, which a lot of your games are. But in general, whenever you're repeating, you'll have multiple instances of the same game object, or rather, you'll have copies of the same game object. what we want to do, the system I have here, very similar to your game engines like Unity and Unreal, is make a prefab for that object, and then just use that prefab to spawn how many ever instances you want. So how do you do that? So you create the recipe for a prefab in your game class. So we will call this enemy prefab, and the signature for that is void game object pointer. So we are saying this enemy game object which will be spawned, whatever we write. Sorry again. So we're saying whatever object we pass into this function, we will have a set of instructions that this function will perform on that object, which will give our enemy the characteristics that we want it to have. So what do we do in this function? So let's define the function here. So we'll have void enemy prefab. Oh, this takes in a game object, like I said. What do we want to do to this? So a lot of it for now would be similar to the player, so I'll just copy all of that. We're not going to have player controls, but we will have the graphic stuff. So let's take that. Yes. All right. So player graphic. So this one will be player graphic. We'll call it enemy graphic. Change the name to enemy graphic. We'll change all these variables to enemy graphic. So obviously we're not attaching it to the player, we're attaching it to whatever enemy game object is passed in. And then finally we need to add the sprite renderer class header over here so that I can use it. And lastly, the image. What is the image? So the image is not going to be the tank image. So I have a separate image called tanks3, which has a bunch of different images for your enemies. You know what? But we'll get to that in a moment. We'll change that in a bit. But this is basically going to be the setup. We'll have a different image, maybe different scales and angles and all of that. But how do I use this? What I want to do is in my scene, I want to spawn a certain, let's say 10 instances of this enemy. How do I do that? So before I can use a prefab in a scene, I have to add it to the list of prefabs in the game. Ideally, this is something you can do in Awake. Yeah, this should be done in Awake actually. Let's So in Awake, I'm going to do add prefab, give it a name. So the first parameter is the name of the prefab. I'll simply call it enemy. And the second parameter, okay, so when you start, this is something I would recommend you do. Whenever you start filling in the parameters of a function, if it is not something you wrote, check the list of parameters that it accepts. So here you can see the first parameter is a string, a standard string. That's what I have, enemy. The second parameter is a standard function with the signature void game object star. That is why our any prefab function has to have that signature. It returns void and it accepts a game object as parameter. So what this is saying is basically prefabs is a list of strings, or it's a dictionary of strings mapped to functions. So when you try to create a prefab with a certain name, it'll look up the dictionary, find what function it corresponds to, and then it'll call that function. Now, how do you do this? Can you think we can, simply do that? Oh, I called it prefab. That's not right. We call prefab. Did I make a mistake here too? Yeah. Prefab. Okay. All right. Now, what happens if I do that? Oh, it's actually not complaining. It should complain. Oh, we'll see. We'll see. Okay. So this should not actually work, and I think it should not work. But anyways, we were saying add enemy prefab to, and set the key as enemy. Now, in our scene, what do we want to do? So let's say we want to spawn 10 of these. So we'll say for int I equals 0, I less than 10. Oops. I want to instantiate this prefab, so I'll say instantiate just like what we've been using. Like I said, whenever you want to spawn a new game object, you use instantiate. And now I will use the prefab. So the prefab is in game. So game, oh, I need to include game so that I can use its functions. So include the game header, and then it becomes game.prefab, and then you pass in the name. So this name has to match whatever you added to the dictionary, the name with which you added to the dictionary, the function we call there. So now we are saying instantiate the enemy prefab. Where do we want to instantiate it? So let's put a random, so instantiate it at a random positions. So let's go with the camera side. So we'll say instantiate it at a random position on the screen. So we'll say rand modulus camera width, comma, camera height. So the camera is essentially a rectangle. XY specifies the X and Y, the starting position, and width and height. So we're saying spawn the enemy somewhere, at a random position, but within our camera's width and height. So let's go ahead and run that. I have, yes, okay. So there we go. So it is complaining. The reason being, enemy prefab, even though it matches the signature void game object star, our game object pointer, it's tied, it's a member function of this class. This function does not have any meaning if it is not tied to an instance of the demo project game class. Now we know that, you know, this is going to be the only demo project game class, so it should be tied to this, but the code does not know that. So we have to bind it to this class. We have to bind it to the instance of this class. So the way we do that is we say bind this function. We have to give it the class name as well. So we are saying bind the enemy prefab function of the demo project game class to this. So this is a reference to the instance that we are at, the instance for which the instance of the game will be spawning. So we're binding this, and then finally, now so we're binding the function to this demo project game, but we know it takes a parameter, the game object parameter. So for that, we need to say, well, we're not giving you the parameter right away. That's just going to be a placeholder for now. And at runtime, someone will give you that parameter, and so that happens somewhere. So this is just saying, oh, I'm missing a bracket here. So this is saying, yeah, so for now it's a placeholder. When this function gets called, someone will pass in that enemy game object that you are expecting. So now we have bound this function to the right context and the parameters. So there we go. So those are the spawn enemies. Now the spawn enemies have the same image because that's what we have here. We don't want to use the same image. I want to use the other image. So we'll do tanks underscore 3.png. So what will happen? This is also not going to be what I want, because this will just spawn the entire sprite. So I'll just show you guys what that image is. So it has all these tank images, and now I'm just spawning all of that, right? So that's not what I want. I want to choose one of them. So let's say I want to choose this guy right here. How do I choose him? So first I have to figure out what the coordinates are. Now you can use Photoshop or something else. I will just use Paint, because that's enough for what I'm trying to do. Where is Paint? There we go. So what I need to do is figure out the pixel coordinates of this image or this portion of the image so that I can crop it. So I can see it's 350, 250. So the top left, so you need to know where the top left is. So that's around 350, 250. And then you need to know the width and height. So I'll check the bottom right. So I go from 350 to around 550. So let's say that's 200. And I go from 250 to nearly 400. So let's say that's 150. So I want to start at 350, 250, and go 200 and 100. Now, how do I do that? So here I want to crop this image. So I'll show you guys. So to do that, what do you need to, there are many ways of doing that, first of all, but the way I'm going to show you, it also introduces the concept of a sprite object. So yeah, I need to figure out how to stop my mic from turning off. Include sprite and also include the class for rectangles, which I've created called rect. So you want to create an object of type sprite. Now, sprite itself, it's different from a sprite renderer. Sprite renderer renders the image on the screen. If you a sprite, if you would like to think about it, it would be the data class for a sprite. So I'll create a sprite called enemy tank, and that will be a new sprite which takes in the path just like the renderer. But now you can also specify a rectangle. So new rectangle, and the parameters are going to be whatever we checked on Paint, in Paint rather. It was, what was it? I forget. 350 and 250. So 350, 250, and we said the width and height are 200 and 150. So the sprite is a data holder for us, a sprite object, an image. The point of using a sprite is really for animations, because we could do this directly, but I'm doing it this way. So you basically create a sprite renderer now with a reference to the sprite that you want to render. So now I'm saying render this enemy tank sprite. Why am I doing it like this? So this will be super useful if you want to do animations. If you want to do animations, create a list of, let's say, 10 sprites, which will be the frames of your animation, and then simply you create one sprite render. You don't want to keep creating and destroying sprite renderers to render a different image. That's not optimal at all. Instead, all you can do is at any point, so this let me not do that right now, it'll be a topic for a future video, but you can simply get the sprite renderer and change the value of the sprite object on the sprite renderer, and basically reuse the renderer to display different images. So that's it. So that's the reason for the sprite class. So let's run it. Let's see. Oh, there we go. So yeah, it looks like it's getting the right image, but it's really small. Why is it really small? That's because we're setting the scale to 0.1 and 0.1. Instead, let me make that a little bigger. Let's do 0.3. Let's do 0.4. I feel like that'll be a good scale. That's better. Actually, you know what? I will go back to 0.3. Just because I want the enemies to be a little smaller than the player. So there we go. So now we have our player moving, but we have also spawned 10 enemies randomly on the screen. Now obviously the enemies don't have any behaviors attached to them, so that's why they're not going to do anything, but we have them spawning. This was the objective of this video. That said, yeah, before I stop, there's one thing you can notice over here. The player is behind the enemy. Why is that happening? Because in STL, or the way the engine is written, when you spawn one object after the other, it is spawned on top of the previous object. So the rendering order is the last object is on top. And that's what is happening. So because we spawn the enemies, the for loop for the enemies is after the player. So that's why the enemies are spawning on top of the player. Now, yes, you can you do this for loop before you spawn the player, and that'll take care of it. However, you know, like I said, you're probably going to spawn enemies at runtime, and you might want the functionality that your player will still be on top of those enemies. How do you do that? Because the player is spawned right in the setup function. Anything spawned at runtime will be, you know, spawned after the player, so it'll appear on top. So for that, I have something called layer. So you can set the layer of a renderer. Okay, yeah, so you can set the layer of a renderer, but I'll do it the same way that I did for the enemies, where I'll create a sprite. So I'll say sprite player sprite equals new sprite, and it'll take the same path just like we did for the enemy, but now I can also okay, for this one I'm not cropping anything. Because I do want the entire sprite to be rendered. But what I'll do is when I'm creating the renderer, I'll pass in the sprite, but it also takes an optional parameter. Also, the sprite the constructor for the renderer with sprite takes an optional parameter called layer. So you can set the layer of the renderer of an object. So how do layers work? Now, layers override the fact the layers override the order in which objects are created. So layer 0 will always be spawned behind layer 1. 0 is the default layer, by the way. So setting the player to layer 1 means no matter when any other enemy is spawned, since they will be on the default layer 0, player will always be rendered on top of those enemies. So yeah, this should work. That said, before I can set the layer to 1, the way the system works right now is before the game starts, you have to specify how many layers are in the game in the first place. So I'll go here. So this is another good candidate for the awake function. Here we will say also the number of layers. So the number of layers is on this script called render module. So because eventually we'll be using the same concept of layers for text and other stuff. So we'll say render module dot number of layers equals 2, because right now we only have 0 and 1. So we're letting, before the renderer is created in init, we are letting the game know that there will be 2 layers that we'll use. Because the thing is, the way it is set up right now, the render module gets created at some point in init, and then if it gets initialized with only 1 layer, it's not aware of the fact that we are setting the player's layer to 1, because that happens later. The scene gets created later. So we need to let the renderer know before it's created how many layers are going to be in the game. So that's what it is. I might eventually add a smarter way of doing this so that the renderer can add more layers on the fly. But for now, you have to specify what the total number of layers are going to be. And then if I run that, and I'll see my player is on top of the enemies, even though the enemies are spawned after the player. So yeah, that's it. Just before I stop, let's just run a quick stress test. What happens if I try to spawn 100 enemies instead of 10? Takes a while to load, but once it loads, it's actually fine. It's still running at 60 frames per second. So yeah, not too bad. So yeah, that's it. I will stop here for this video. Next video, we're going to pick it up from here, add some behavior to the enemies. Thank you for watching.